Hello, my name is Kat Robershaw. I'm a doctoral candidate and an instructor in the Department of Educational Policy Studies and Evaluation, University of Kentucky. And today I would like to talk about how to estimate treatment effect of teachers' professional development on student achievement with optimal multi-level matching. In this study, we have collected the demographic data, the reading achievement scores from a total of 1,815 students to estimate the treatment effect of teachers' participation in a year-long professional development on students' academic achievement. However, the students from the treatment group and the comparison group are not comparable based on certain student covariates, such as average grade level, initial status of reading achievement scores, and English language learners or ELLs status. Also, I recognized the multi-level nature in this analysis on student achievement as the treatment was implemented at the teacher's level. As a result, optimal multi-level matching method using a network algorithm by Keele, Pimentel, and Rosenbaum in 2018, which is an R statistical package, was employed to match comparison groups on both student and teacher or classroom levels, while randomization inference was employed to estimate the treatment effect of the teacher's professional development on student achievement. This study demonstrates the application of optimal multi-level matching procedures and randomization inference to estimate treatment effect in educational program evaluation. To begin with, I would like to give you some background information on optimal multi-level matching using a network algorithm. Generally, the goal of matching datasets is to pre-process the data prior to the parametric analysis so that the actual relationship between the treatment variable and covariates is eliminated or reduced without introducing bias prior to the treatment estimation. Optimal multi-level matching using a network algorithm is a very appropriate method considering the structure and hierarchy of our data. This method performs multi-level matches for data with cluster-level treatments and individual-level outcomes using a network optimization algorithm. Functions for checking balance at the cluster and individual levels are also provided, as are methods for permutation inference-based outcome analysis. The R package Match Multi, which provides these functions in the 64-bit version of R.3.6.2, was used for this analysis. Our research question is how effective is the teacher's professional development program on students' reading achievement? I will now go through the steps of conducting this study. First, I needed to develop a matched comparison group, that is, to find the most comparable student from the control group to match with another one from the treatment for fair comparison. The R statistical software requires the dataset to be without any missing values. So evaluators cleaned and dealt with the missing values from the dataset prior to the analysis. The binary treatment variable is coded as the outcome variable in the matching procedure. I examined the following student and teacher covariates for potential inclusion in the matching procedure. So for student variables, we have gender, race, grade, ELL status, or English language learner status, the reading map scores from the year 2018 to 19, and for teacher variables, we have classes with 33.3% or more minority students. They will be coded as 1, whereas classes with fewer than 33.3% minority students will be coded as 0. We also look at the class size. Student-teacher ratio less than 30 to 1 will be coded as 1, and and any ratio larger than that will be coded as 0. After linking these student and teacher covariates into the dataset, the next step is I performed balance checking on both level 1, which is student, and level 2, which is teacher, covariates using the balance table function from the match multi package. Table 2 reports results of balance statistics using treated and control means, standardized differences, which is the difference in means divided by the pooled standard deviation before matching, and p-values from the parametric and non-parametric tests including Fisher's exact test and Wilcoxon signed rank test. In this case, the covariates above were examined to see which ones had a significant impact on predicting whether a student would or would not be taught by a teacher who was participating in the teacher training. The balanced statistics before matching show that, with reading achievement as the outcome variable, all selected covariates except for gender, the percentage of minority students in class, and class size, they all had significant impact on whether a student was likely to be treated through teachers' participation in the teaching training. Covariates that have no statistical significant impact on the likelihood of a student being in a treatment were therefore removed from the matching procedure. Step 3 is the actual matching procedure itself. The optimal multi-level matching procedure first matches students within each pairwise comparison, a combination of teacher or classroom. Based on these matches, a distance matrix is generated for the teachers. Then teachers are matched on this distance matrix, and the student matches for the selected teacher pairs are combined into a single matched sample. And then the next step was to perform optimal matching at both the student and teacher level. For this step, the teacher covariates are not used to compute the distance matrix for teachers, since it is generated from the student match. Instead, imbalances of teacher covariates are addressed through an argument in the R match multi package named school.fb, which encodes a refined covariate balance constraint. Teacher covariates in school.fb are given in order of priority for balance, since the matching algorithm optimally balances and interaction of the variables in the first list element, then attempts to further balance the interaction in the second element, and so on. Step 4 is balance checking after matching procedure. Table 3 summarizes the balance statistics results comparing the covariates between treated and control groups before and after matching to assess if the student covariates selected were appropriately matched. As illustrated in Table 2, prior to matching, there was a significant difference between in all the variables between the treated and comparison students. But after matching, please look at the numbers in green. The variables are more similar across groups, and the differences are no longer statistically significant. All right. So you can see the comparison for each variable before and after the matching procedure. After matching the dataset on both the student and teacher levels, step 5 is treatment estimation analysis using randomization inference, which is performed by match multi outcome function in the R package match multi as an outcome analysis for the matched data. All treatment estimation results in this outcome analysis are based on randomization inference. Randomization inference is a method of calculating regression p-values that take into account any variations in randomized control trial data that arise from randomization itself. Randomization inference considers what would have occurred under not only the randomization that happened to be selected for the experiment, but rather under all possible random assignments. Would the results hold? The match multi-outcome function returns a point estimate, 95% confidence interval, and p-values for the matched multi-level data. This table summarizes the analysis results after simulating all possible randomizations, random assignments, and counterfactual outcomes using randomization inference. Under the sharp null hypothesis, our teacher training's treatment estimation with growth in reading map scores as the outcome variable obtains a point estimate of 1.99998. With the one-sided p-value for the test of sharp null hypothesis being 0.04. It means that only 4% of all random assignments produce an estimate of 1.99998 or more, even in the absence of any treatment effect. The effect size is moderate at 0.4842. So, how do we interpret the results? One of the advantages of conducting a randomized trial is that the researcher knows that the precise procedure by which the units were allocated to treatment and control. Randomization inference considers what would have happened under all possible random assignments, not just the one that happened to be selected for the experiment at hand. Against the backdrop of all possible random assignments, is the actual experimental result unusual? How unusual is it? The sharp null hypothesis of no treatment effect for any unit is a skeptical worldview that allows us to stipulate all the counterfactual outcomes. If there were no treatment effect for any unit, then all the control units' outcomes would have been unchanged had they been placed in treatment. Similarly, the treatment units' outcomes would have been unchanged had they been placed in the control group. And under the sharp null hypothesis, we therefore have a complete mapping from our data to the outcomes of all possible experiments. And all we need to do is to construct all possible random assignments and, for each one, calculate the test statistic, which is the difference in means between the assigned treatment group and the assigned control group. The collection of these test statistics over all possible random assignments creates a reference distribution under the null hypothesis. And if we want to know how unusual our actual experimental test statistic is, we compare it to the reference distribution. Okay, so in our study that I have selected to present today, the one-sided p-value for the test of sharp null hypothesis is 0.04, which means, as I said earlier, only at most 4% of all the random assignments exhibit and the reading map score growth of 1.99998 or more, even in the absence of the treatment itself. I think I said that earlier I talked about that in my last slide. So the results of this study found that students whose teacher participated in the professional development exhibit significant positive growth in their reading achievement scores. However, a limitation of this study is the assumption that teacher participants fully implemented is the assumption that teacher participants had fully implemented what they learned from the professional development program in their classrooms. And I hope that this presentation again gives you an overview of how to apply optimal multi-level matching procedures and randomization inference from the R package named Match Multi to estimate treatment effect in educational program evaluation. And this is the end of my presentation. I appreciate any feedback, thoughts, suggestions, and insights from all of you. Thank you.